Hello, and welcome to Easy as Pie with Mr. Carpenter. I, of course, am Mr. Carpenter. Today's video is being recorded out in the beautiful purple chairs that lead up to the entrance to STEM. So if you hear some rustling and bustling out in the hallways, don't mind that. I thought a different location would spice things up. Greatest common factor is our topic for today, and it is one of the more important factoring techniques for both algebra and algebra 2. So it's important that you have a good grip on it. When we think of a greatest common factor of a set of numbers or a collection of terms, what we're thinking of is the largest possible number that we can think of that will divide nicely into all the terms. For example, let's just start with numbers, right? 6 plus 9 plus 15. Okay, now in this case, I have to think of the biggest number that would divide nicely into all three numbers, right? And it's not 6 because 9 divided by 6 is going to be 3 over 2, which is going to be a decimal. Not going to be 2 because 9 divided by 2 would be a decimal. It would have to be 3, right? Because 6 divided by 3 is 2, 9 divided by 3 is 3, and 15 divided by 3 is 5. And there is no number greater than 3 that will accomplish that. So in this case, the greatest common factor would be 3. So I'm going to start by writing my greatest common factor down and starting my parentheses. And what's going to go inside the parentheses is going to be what happens when I divide each term by the greatest common factor, right? So I'm going to start with 6 divided by 3, which is 2, plus 9 divided by 3, which is 3, plus 15 divided by 3, which is 5. And then I can close up shop, which means I can close up the parentheses. And this would be what happens when I use greatest common factor. Now, to check your answer, what you could do is simply distribute the greatest common factor across all the terms, and you should get back to where you started. For example, 3 times 2 is 6, 3 times 3 is 9, 3 times 5 is 15. And I am back to where I started. So I factored that correctly. So let's take this and just move it over here for the time being and work on one with just variables. So we know how to greatest common factor numbers. How about x to the 4th plus x cubed minus x squared? So since every term here contains a common variable, we do have a greatest common factor here. And the way I like to think of it is like this. So this is x to the 4th, so that's 4x's. Plus, this is x cubed, so that's 3x's. Minus, that's x squared, so that's 2x's. So what is the greatest amount of x's that any term could contribute, right? And the answer would have to be 2, because every term has at least 2 x's. So when we're thinking about factoring out variables, what we're looking for is a variable with the smallest exponent, because as you can see, that's going to be the one that every single term can contribute. So I would factor out an x squared, and then I could start my parentheses. And now it's x to the 4th divided by x squared. And since we're using our quotient rule, right, when we divide these bases, we're going to subtract their exponents. So x to the power of 4 minus 2 is 2, plus x cubed divided by x squared, that's x to the power of 3 minus 2, which is x to the 1st, which will just be x, minus x squared divided by x squared. Any number divided by itself is just 1. And that would be another example of greatest common factor in action. So now, the most complicated that it can get is when we combine both of these together, right? So I'd have to factor out both a number and a variable. at the same time. For example, 6x to the fourth minus 8x cubed plus 10x. So how would we go about this? Well, first, we need to see if there's a greatest common factor of the numbers. So looking specifically at 6, -8, and 10, is there a greatest common factor? Well, that would have to be 2, because 2 is the largest number we can think of that goes nicely into 6, -8, and 10. Then we look at the variables, x to the fourth, x cubed, and x. They all share a variable, so I can factor out a variable. Which one has the smallest exponent? That would be x to the power of 1. So in this case, the greatest common factor would be 2x. Then I start my parentheses, and what goes inside the parentheses, I will divide each term by the greatest common factor. And I'll start with the numbers, and then I can move on to the variables. So with this first term, 6x to the fourth divided by 2x. Well, we have 6 divided by 2, which is 3. And then we have x to the fourth divided by x to the power of 1. So that would be x to the power of 4 minus 1, which is 3. Minus 8 divided by 2 is 4. X cubed divided by x would be x to the power of 3 minus 1, which is x squared. Plus 10 divided by 2 is 5. And x divided by x will cancel out because they divide out to 1. And I'm not going to do 5 times 1, so I'm just going to leave it be. And then I can close up shop. And this is an example of GCF that involves numbers and variables. And remember, if you are able to take a greatest common factor, then this is your first priority. If you are allowed to take a greatest common factor of a term when you're factoring, that is what you're going to do first. And from there, you can evaluate to see if you're going to use other strategies. So with that in mind, that's greatest common factor. Thank you so much for watching, and I'll see you in the next.